This video is going to take a quick look at hyperbolas. This is section 10.4, the hyperbola. And we're going to focus on graphing hyperbolas and describing key components of the graph of a hyperbola in this video. We're not going to focus necessarily on the geometric definition of the hyperbola or a proof of the formula for the hyperbola. We're just going to start with the formula and answer the question of how do I graph a hyperbola? And if I know the equation of a hyperbola, how do I find the key components of that graph? So let's start by just writing down the equation of a hyperbola. Now, hyperbolas can either open right and left or up and down. Until we get to the section in Precalculus that allows us to rotate conics, words are hard. Our hyperbola will either open to the right and left or it'll open up and down. Okay? So we're going to start with this equation. We're going to start with x squared divided by a squared minus y squared divided by b squared equals 1, where b squared is equal to c squared minus a squared. Now there's a couple of key differences between this formula and the formula for the ellipse. First of all, the hyperbola has a minus, and instead of it being b squared equals a squared minus c squared, it's b squared equals c squared minus a squared. Now what do we know about this hyperbola? Well, this hyperbola has a positive in front of the x and a negative in front of the y. Since the x is positive, when we graph this hyperbola, when we draw its graph, our hyperbola is going to have a vertex. For this specific example, it's going to have vertices on the x-axis. And our hyperbola, is going to open like this. We say this opens in the x direction. Because the x is positive, we know our hyperbola is going to open in the x direction. So this is the graph of a hyperbola. Now we want to label all the important characteristics of this graph so that when they ask us to find them in the homework, we'll know what they're asking us to find. First, a hyperbola has a center. The center of this hyperbola is 0, 0, right? So the center is 0, 0. Now, it doesn't fit the traditional definition of a center, like the center of a circle or the center of a square. The center of a hyperbola, right? The center of a hyperbola is the midpoint of the transverse axis. Now, what's the transverse axis? Well, the transverse axis is the axis that goes through the two vertices. So it also goes through the two foci. So we need to label these points. This point here, right? This is a vertex. This point over here is also a vertex. So a hyperbola has two vertices. Two. Now, for our problem, because our center is at 0, 0, and we know our center is at 0, 0 because remember, this is x minus 0 squared, and this is y minus 0 squared. Just like from back when we were talking about our ellipse or our circle. So our center is at 0, 0. So our vertex, right, our vertex is going to be the point A0. And over here, negative A0. And that a, of course, is under the x, so that's how far we move in the x direction. We call this the transverse axis. The transverse axis is the axis that goes through the two vertices of a hyperbola. Now, hyperbolas also have foci. They also have, just like an ellipse, a hyperbola has two foci. So where is one? Well, one focus is going to be here, and the other focus is going to be here. It's very similar to the parabola in the sense that the focus is inside the curve of the hyperbola. So this point here is going to be a focus. And this point right here is also going to be a focus. Now we need the coordinates of those points. And remember, when we found the focus of an ellipse, C was the distance from the center to the focus, and once again, that is going to be the case here. So the coordinates of this point right here are going to be C, 0, and the coordinates of this point right here are going to, of course, be negative C, 0. So, this distance is C, and this distance is C. That's how far our focus is from our center. Our focus is C units from our center. And then our vertices are A units from the center, right? Our vertices are A units from the center. This distance right here is A, and this distance right here is A. Now, as you can see on this graph, right, on this graph, we don't have B any place on this graph. There's no point on this graph where B is going to be used to graph that point. The key points of a hyperbola are going to be the vertices, which are going to lie on the transverse axis, and the foci, which lie on the transverse axis. Since our hyperbola opens in the x direction, those points are going to be on the x-axis. Now remember, if we were to change this formula, and we'll do a couple of problems before I end the video, but if this was going to be x minus 2 and y minus 7, then we're not going to have our center at 0, 0. This is just our first example. Now, there's also the other case, right? There's the other case. What's the other case? Well, the other case is where instead of the x squared term being positive, we have the y squared term being positive. So we would have y squared over a squared minus x squared over b squared equals 1, where b squared equals c squared minus a squared. Now, what's different in this equation? The difference in this equation, of course, is instead of x being positive, y is our positive term. Now, what does that mean? That means since y is our positive term, our hyperbola is going to open up and down. It's going to open in the y direction. So our hyperbola is going to look like this. And just like in the case where it opens in the x direction, this point right here is going to be a vertex. This point right here is also going to be a vertex. Now you'll notice when I wrote the equation, I put the a under the y. That's something that we're going to have to make sure we write in our notes. A goes under the positive term. It goes under the positive term. In the case of the ellipse, a is the biggest value. A is the largest number. When I look at my two denominators, I look at them and I say, which one's the biggest one? Oh, that one's larger. That one's going to be a. That is not the case with the hyperbola. A does not have to be bigger than b. A could be smaller than b in the case of the hyperbola. We know The denominator of the positive term is always a squared, always. Okay? So the coordinates of this vertex, the coordinates of the vertex are going to be 0 for our x, a for our y, and the coordinates of this vertex here is going to be 0 for x, negative a for y. So we're always going to have an a in our vertex. It may be the x turns out to be a over here. It may be the y that turns out to be a over here. It's easy to tell the difference. You just think to yourself, this one opens up and down. So the a is under the y, so I'm going to have it on the y-axis. So here my transverse axis, right, my transverse axis is going to be the y-axis. Now where is the center? The center is the midpoint between the two vertices. So over here our center, right, our center is still 0, 0. We should add to our notes over here that the transverse axis is the x-axis, right? Over here we said the transverse axis is the y-axis. Okay. Now we also know this distance here is a, right? This distance here is a, just like before, and this distance here is also a. So the distance between the two vertices is 2 a's, a plus a. Now again, we're going to have foci over here, and the foci are going to be inside. They're going to be right here, and they're going to be right here. And we know what these points are going to be, right? This is a focus, and that coordinate is 0, negative c. This over here is a focus, and that coordinate is going to, the coordinates are going to be 0, positive c. And of course, the distance from the center to the focus is going to be c in both cases. Okay? So, those are the key pieces to the graph of a hyperbola. We're going to do some examples and work out some problems, and then we will begin to see what kind of questions they're going to ask us and how will I use these pictures. So don't lose these. I'm going to erase them off my whiteboard, but you're going to need them in your notes when we go through the examples. Okay? So let me erase these. All right, so what's a typical problem that we're going to encounter going to look like? Well, the most basic problem, right, the beginning exercise is going to be something like this. It's going to say, here's our example. We'll say x squared over 16 minus y squared over 4 equals 1. And it's going to say, analyze this equation. Now what do they mean by that? Well, they want us to tell them, right, where's the center? Where are the foci? And then they want us to draw the graph. So what do we look at when we write this down? Well, we notice the x squared is positive. So this is going to open down and up. Right? So we know that. We have to find the center, right? That's one of the things we have to find. We can rewrite this. This is really x minus 0 squared over 4 squared, isn't it? 16 is 4 squared. Minus y minus 0 squared over 2 squared equals 1. And we can see our center right there. Our center is going to be 0, 0. So once we have the center, we can start drawing the graph, right? We can come over here, and we can start drawing our graph. We already have the center. Now the center is not a point on our hyperbola, but we know the center goes here for this problem, 0, 0. Now, from our previous example, we said this is going to open, right? X down and up. Should be fired from making these videos. This is going to open. Thank you, by the way, for all of you yelling at your computer. This is going to open right and left, huh? So we know our hyperbola is going to go like this. This is the way our hyperbola is going to go because the x is positive. We said the vertices are going to be on the x-axis. If the center is at 0, 0, and our x is positive, our vertices land on the x-axis. Now, how are we going to draw the graph? Well, we're going to use the box method, just like we did back in the ellipse. We're going to draw our box. We're going to do exactly what we did with the ellipse and draw the box, and that's going to help us draw the graph. So in the ellipse, we had to find A and we had to find B so we could draw our box. Now remember, with the ellipse, A was always the biggest number. But for the hyperbola, A is whoever is under the positive term. This one's plus, this one's minus, that's A. So A is 4. Okay, B is 2. So what do? I count 4. And I count 4. And I'm going to make my box because I'm going in the x direction 4. In the y direction, right, 2 is under the y, I'm going to go 2 in the y direction. So I'm going to make my box, it's going to look like this when I get done. All right, so this is very similar to what we did for the ellipse. Very similar. We're going to make our box just like we did before. All right, so we have our box here. Let's just go ahead and finish it. Now, if we were graphing an ellipse, we'd be done. We'd just draw our ellipse, we'd be finished. But we're not graphing an ellipse. We're graphing a hyperbola. So what do we do to change the box method from making an ellipse where we just connect these 4 points to making a hyperbola? Well, we draw what are called the asymptotes for the hyperbola. Hyperbolas have asymptotes, so we have to draw those. Now, how do we draw those? Well, the easiest way, and the reason I like the box method, is because if you use the box method, then you're going to draw your asymptotes by just drawing a diagonal through your box. So we can draw a diagonal through our box and draw the other diagonal through our box. And we have the asymptotes for our hyperbola already drawn. Okay? So that's why the box method for the hyperbola is so nice. It helps us draw our asymptotes really quickly. We just draw the diagonals to our box. So we've gone 4 in the x direction from our center, which happened to be 0, 0 for this first problem. And then 2 in the y direction from our center, 4 and 2. 4 under the x, 2 under the y. Now, we know that our vertices, right? We know where our vertices are located. Our vertices, because our x term is positive, they're going to be here and here, right? So those are our vertices. And now we can draw our hyperbola. Remember, these are asymptotes. Asymptotes in this case, in the case of a hyperbola doesn't cross its asymptotes. So we draw our hyperbola like this. And we've got the graph of the hyperbola. We know this point. If we were doing this for a test, we would have to label these points, right? This is the vertex. This is 4, 0. This is also the vertex. This is negative 4, 0. So if on the test they asked us to find the center and maybe they asked us for the vertex, we could say, and it wouldn't be vertex, would it? Because we have more than one vertex, right? So it would be vertices. We know our vertices are going to be 4, 0, and negative 4, 0. Now, The other 2 points we need, right? The other 2 points we need are the foci. We have to find the foci. Now remember, to find the foci, we have to use the formula b squared equals c squared minus a squared, right? That's our formula for the foci. We have to remember that formula. It's not part of our equation up here. So we know our b squared is 2 squared, so our b squared is 4. C squared we have to find. A squared for us is 16, isn't it? A squared is 16. So what do we get? We get c squared equals 20, or c equals 2 square root 5 when we simplify that by taking the square root of both sides. So that tells me where to go for my focus. One focus is at this point right here, right, which we know now is 2 square root 5 comma 0. And the other focus is right here, which we know is negative 2 square root 5 comma 0. So if they asked us for the foci on the test, right, if they asked us for the foci on the test, we would write 2 square root 5 comma 0 and negative 2 square root 5 comma 0. And we've got our graph. Okay. So, let's do another problem. Okay, let's do another one. Let's clear this off. Okay, I'll go ahead and erase this. All right. So let's try another problem. That was a problem where they just ask us to draw the graph, right? Let's do a problem where it may not be the case that our hyperbola is centered at 0, 0. Maybe the center isn't going to be 0, 0. Now this is nothing to be afraid of, right? So let's just write something down like this. Here's our example. We have negative x squared plus 4y squared minus 2x minus 16y plus 11 equals 0. Now, this does not look like the hyperbola that we were hoping to see. It's not in our nice format. So we're going to have to complete the square. Right? That's what we're going to have to do. We're going to have to complete the square to find the answer, to find A and to find B and to find our center. And this is typically the way these problems work out. They want us to practice our completing the square. So I'm going to rewrite this. I'm going to put this as negative x squared. I'm going to put the minus 2x right next to that. Then I'm going to put the 4y squared right here, put the 16y next to that. And I'm going to go ahead and move the 11 to the other side. Okay. Now, before I complete the square, I'm going to factor a negative out of this. That's going to give me x squared plus 2x. Now I'm going to complete the square, so I'm going to leave a slot there. Plus, over here we have 4y squared minus 16y. I'm going to leave a slot there, and that equals negative 11. But if we take a look at this, and if we did well in our Algebra 2 class, and if we're going to do well in our pre-calc class, we're going to make up for the things that we might have forgotten in our Algebra 2 class. We can't have a 4 here. You can't have a 4 in front of the y squared. You can only complete the square if the coefficient of the squared term is positive 1. That's why I took the negative out over here. So I need to write this again. I need to recopy this again. This I'm not going to change because we were perfectly ready over there. Here I got to factor out a 4. Okay, I got to remember to factor out that 4. Now remember, how do we complete the square? Well, my suggested methodology is you identify b. B is 2. You take half of b. That's going to be 1. And then you square what you just got. That's going to be 1. This goes right there, right? This goes here. Now I'm going to put a box around this because I'm not very good at factoring, and I'll get to that in a second. Over here, b is going to be negative 4. Half of that is going to be negative 2. I'm going to put a box around that. And 1/2 b squared is going to be positive 4. That goes right there. Now we have to balance on the other side. We've added negative 1 to this side. Don't lose that negative sign. We've added negative 1 to this side. So we've got to add negative 1 to that side. Over here, we've added 4 times 4. We've added 16. So I have to add 16 to this side. All right, we got to be careful about those algebra 2 kind of mistakes that we make. We don't want to be making those kind of mistakes in pre-calc. Now this factors. I don't have to think about it. If I know how to do my b, half of b squared, all I have to do is look at the middle one, the one I put in a box. It's a 1. You know what that means? That means that's a positive 1. That means this factors as x plus 1. I just look right there and I'm done factoring. I don't even have to think about it. Now, there's going to be a minus there. Plus, I have a 4 here. Right, I have 4. How do I factor that? Well, I don't think about it. I just look in the box. There's a minus 2. So that's y minus 2 squared. I'm sorry, I forgot the squared there. And this equals 16. Now we're getting closer, right? We can actually see our center. We're getting closer. Now what do we have to do? This has to be a 1. So I've got to divide everybody by 16. And when I do that, what do I get? I get minus x plus 1 squared over 16. 4 goes into 16, that gives me a 4. So I get plus y minus 2 squared over 4 equals 1, and there it is. There's the equation of my hyperbola. Now I can start doing all my work. Now I can start thinking to myself, which way does it open? What's my graph going to look like? Right? I can graph my hyperbola, because if I graph it, I'm going to be able to find all my parts and pieces. Now, I'm going to write under here, I'm going to write this as 4 squared, isn't it? I'm going to write this as 2 squared, isn't it? Which one of those is A? Which one is A? A is 2. Because remember, A is under the positive one. So here's what we know right now. We know our center, don't we? We know where our center is. Our center is negative 1, positive 2. We know A is 2 because it's under the positive term. B is 4. Now remember what I said earlier in the video. A doesn't have to be the smaller. The larger. In this case, it turns out to be the smaller. So how do we draw our graph? We draw our box. We go to our center. Our center is x is negative 1. Y is 2. This is our center. Right? That's our center. Negative 1, 2. Now, we start doing our counting. Right? We do our counting. A is 2. A is under the y. A is under the y. So we're going to go 2 in the y direction and down 2, right? Up 2, down 2 in the y direction. 4 is under the x. 4 is my b. It's under the x. So I'm going to go 4. 1, 2, 3, 4 in the x direction. And then 1, 2, 3, 4 in the x direction. Right? And that's going to give me my box. So now I can draw my box. My box is going to look like this. Now remember, we're drawing the box so we can draw our asymptotes. Now I've got my box. So I need my asymptotes, and I draw the diagonals of my box to get my asymptotes. Okay, now which way does our hyperbola open? Which way does it open? Which of these two terms is positive? The y term is positive. So our hyperbola, this is going to be the vertex. Right? And this is going to be the vertex because it's going to open in the y direction. So that's the graph of our hyperbola. Now we have to label all the appropriate points. We can't just stop here on the graph. We have to label the vertex. So this is one vertex. This is negative 1, 0. This is another vertex, right? This is negative 1, 1, 2, 3, 4. So over here we would have to add this. Our vertices are negative 1, 0, and negative 1, 4, right? Those are our vertices. Now we need our foci. Now to find our foci, we've got to do some arithmetic, don't we? We have to figure out the solution to b squared equals c squared minus a squared. Now our b squared, right? Our b squared is 16. Our a squared is 4. So that gives us 20 equals c squared, or c equals, it turns out to be, doesn't it? It turns out to be the same number we found before, 2 root 5. Now let's be careful here. We don't want to get all quick and crazy and mess this up. One of our foci is right here, isn't it? Because this, remember, this line right here is our transverse axis, right? This is our transverse axis. It's the axis that goes right through the center and right through the vertices. Our foci live on the transverse axis. So we'll put one foci here. We'll put the other foci right here. Now we need to label those points. Now we got to be careful. The x is easy. Right, we went straight up and down from the center, so the x is going to be negative 1. But what's the y going to be? Right? It's not going to be negative 2 root 5. We didn't start at 0. We started at 2, right? We didn't label our vertex. We should do that. Our vertex is negative 1, 2. We started at 2. So we have to make sure we realize we started at 2 and we went down 2 root 5. We got to write 2 minus 2 root 5. We started at positive 2. And this point right here, negative 1, we started at 2 and we went up 2 root 5. Okay? Now remember, this distance is A. This distance is c. We didn't talk about it any other time until now. This distance, of course, right? This distance right here, this distance is b, isn't it? Now, the distances, the distance, right? The distance between the vertices is 2a, right? Because it's a this way and a this way. And remember, we said this was the transverse axis. As it turns out, this line, the line that goes through, now these points are not vertices. Look at them, they're not vertices. But this axis also has a name when it comes to the hyperbola. Okay. This axis also has a name. It's not the transverse axis. It's called the conjugate axis. Just in case you get a tricky problem in the homework that asks you about the conjugate axis, I want to make sure that I label that for you. All right? So that's our video on section 10.4. If you're in my class, right? If you're in my class, your homework, now this is Mr. Rainier's class, this is not Mrs. Tedder or Mrs. Rainier's class. If you're in Mrs. Tedder or Mrs. Rainier's class, they've already told you your homework. But if you're in Mr. Rainier's class, our homework is number 15 through 61 odd. Okay, 15 through 61 odd. That's our homework from section 10.4. All right, thank you very much.